Okay, we're going to do a couple of two examples in this video of using the technique of u-substitution. A little more doing the problems and less explanation. So here we go. Let's get right into this problem. This is on page 126. It's number 3 in your study guide, and we're to find the integral of the square root of 5x minus 2 dx. Integration problems, not just u-substitution, but integration generally just requires a good deal more cleverness and perseverance to find the answers sometimes. This is a u-substitution problem. It can't be integrated without using u-substitution, and it appears to be unintegratable. But if we use the technique of u-substitution, we'll find out that it is integratable. First thing to do is to find a u. So we'll set up a u. We have to pick some part of this function to be u, and this is the part that takes some cleverness and experience. The u we're going to use here is 5x minus 2. Now, if you recall, what we need to do next is differentiate both sides of this. In other words, differentiate this equation. Du dx equals 5. And we would multiply both sides of this equation. These steps are always done in using u-substitution. Pick a u, differentiate, multiply both sides by dx, and we get this expression, du equals 5 dx. Now, once we've gotten to this point, it's time to take a little break and come back over to our integral and start making the substitution. We've taken out 5x minus 2, and we've replaced it with u. And once we've done that, we can see that this part of the equation has been replaced, substituted. What's left over here is this dx. We need an exact replacement for dx. Okay, so let's look over here. We don't have that just yet. What we have is that du equals 5 dx. What I need is exactly dx, and so clearly what I need to do here is divide both sides by 5. Multiply both sides by 1/5, and that will cancel this 5, and that will leave me with just dx on the right side, which is exactly what I need. Okay? On the left side is the replacement for dx. We have 1/5 du. Okay, so now we can come over here, we can take this 1/5 du, we'll take out the dx and replace it with, I'm going to go ahead and put this constant outside where it belongs, and 1/5, and the du we can leave inside the integral. Now, the goal of u-substitution, again, is to take a function that's not integratable and replace it with something that is. And this should be pretty straightforward. To integrate the square root of u, du, we'll change the square root of u to be a power of u. Here we'll have 1/5 times u to the 1/2 power du. Okay, to find the antiderivative of this, we'll add 1 to the power. 1/2 plus 1 is 3/2, and then multiply by the reciprocal of 3/2, which is, oops, I just did that wrong. Multiply by the reciprocal of 3/2, which is 2/3, and add our constant. We can multiply these constants together. We'll have 2 over 15 times u to the 3/2 plus c. Now, oops, here's what I meant to put in there was u to the 3/2 plus c. And the last step is our back substitution. That's where we return the function to be in terms of x, which is what we started with. And here is what we have is that u equals 5x minus 2, and so we need to take out the u and replace it with 5x minus 2. And this is our correct answer. 2 over 15 times 5x minus 2 to the 3/2 power plus a constant. Or we could write this as a radical, 2/15 times the square root of 5x minus 2 to the third power plus a constant. Now you should go through the process of checking this by differentiating. If you differentiate this function using the chain rule, you'll find that we end up with square root of 5x minus 2. Okay, let's do another problem. Number 6 on the same page. Okay, this looks a little bit more like the classical u-substitution problems that we're going to be doing. We have a number of functions. Notice we have an inside function here. This function is inside of the square root. And then we have an outside function. The inside function is most often what we're going to choose to be u. Another hint, another thing to look for is we're looking for a function to be our u that is, actually, think about it this way. 1 minus 4x to the third, if you differentiate this, what we'd get is negative 12x squared. Okay? The fact that this is x to the third and the derivative of x to the third is some constant times x squared indicates to us that this is the original function, this is our u, and this is the derivative of the original function. This is the part that's u, this is the part of the function that was differentiated using the chain rule that slid all the way through to the end without being changed. So let's get right into it. U equals 1 minus 4x to the third. Again, this part of the solving these problems always goes down the same way. Differentiate both sides. Du dx equals negative 12x squared. Multiply both sides by dx. We get du equals negative 12x squared dx. Now it's time to go back to our original integral. Start making some substitutions. This part of the function, 1 minus 4x to the third, is u. And again, what we have to replace is we need a replacement for x squared and dx. Okay? And we're very close to that here. You can see the du equals negative 1/12 x squared dx. There's our x squared dx. To kind of manufacture our replacement, all we need to do here is multiply times negative 1/12 on both sides. Negative 12 times negative 1/12 is 1, that cancels. And what we get here is that our replacement for x squared dx is negative 1/12 du. Okay, let's make that substitution. Here we'll have negative 1/12, and here we'll have du. Now we can integrate this. Oops, 1/12. U to the 1/2 du. We've done this enough times that it should start becoming a little kind of automatic. Negative 1/12 times the antiderivative of u to the 1/2 is add 1 to the power, multiply by the reciprocal. Oops, that's a 3. Okay, let me try that again. The antiderivative of u to the 1/2 is 2/3 u to the 3/2 plus a constant. Now we can multiply these constants together. The 2 cancels with the 12 and leaves 6. Here we'll get negative 1/18 u to the 3/2 plus a constant. This is u, except we're going to back substitute now. We're going to take out the u and replace it with the equivalent expression in x, 1 minus 4x to the third to the 3/2 power. Or negative 1/18 times the square root of 1 minus, what happened here? 1 minus 4x to the third. Having some equipment malfunctions here, to the third power plus c. Now if you stare at that a little bit, you'll see that those two are equivalent, and that's the right answer, I think. Yes, I think so. Now, if you differentiate this, you'll find that the derivative of this is exactly x squared times the square root of 1 minus 4x to the third. Thanks for watching.